Ridge regression and linear regression are two popular algorithms that are used for regression problems with some differences. Now, in terms of objective function, with ridge regression, again, it uses something called L2 regularization, right? What this means is just the sum of squares of the coefficients, right? Now, the purpose of using L2 is to just minimize or reduce the magnitude of the coefficient. This helps with preventing overfitting, right? And when we look at linear regression, simply just the objective function here just includes the sum of the squared errors between the prediction, and the actual values, right? In terms of regularization, again, we've already seen that L2 is being used in ridge regression. In linear, we don't have that. So again, L2 regularization here just adds a penalty, right, to the objective function. This helps with reducing overfitting, right? Again, in terms of bias variance trade-off, with ridge regression, using that L2 regularization brings some benefits, right? In terms of reducing the variance of the model while increasing the bias, right? On the other hand, using linear regression, it just provides a high variance in the model and low bias. This most times might lead to overfitting, right? And especially where we have a lot of noise in the data. In terms of outliers, ridge regression is very robust or more robust in the data than linear regression. Why? Because of the L2 regularization, which kind of just discourages, okay, the model from being influenced too much by outliers. And lastly here, in terms of hyperparameters, ridge has one hyperparameter called alpha, which can help us to kind of just fine tune it a little bit. Linear regression doesn't have any hyperparameters. Having said that, let's go to implementation. So we load our ridge regression class here or function. Then we instantiate this model, right, with the alpha there, and we call this RR_model, right? So this is our instance of our model here. So we can now use two methods, the .fit and .predict, right? So the first thing is to do that .fit, right? We want to establish the relationship between, our X, our features, and our target variables, right? We need to map that. And then we use that to predict now, right? So we want to predict, and we want to store this into a variable called y_pred_rr. And then now we need to evaluate this using the metrics. So from the metrics module, we want to get this function for r². And then we pass now, our actual value. Remember, this came from the train test split, y test, and y hat, right? Y hat is what we are predicting here. Just generates an array of all the, possible predicted y. And then this is our actual y. And then also RMSE, we do that. And when we run this, you can see it's actually comparable with what we had in linear regression, right? So if I just scroll up here, you can see in linear regression, we got also 91.64. So they're actually comparable. In fact, ridge regression is a variant of linear regression with those differences that I've just mentioned. Okay, and we can also display the actual versus predicted using SNS, which is just Seaborn from the Seaborn library. You can see the actual value of the price and predicted. They're almost comparable, normally distributed. So our model is doing really well in terms of fitting a line, right, and minimizing the differences between the predicted y and the actual y. So that's the goal of the objective function. In another video, we'll look at other different regression classifiers like KNN.